Hello everyone, I'm Xiaochuan. Today I'm gonna talk about the stratospheric ozone trends in mid-latitudes. Based on the location, ozone can be characterized as stratospheric ozone and tropospheric ozone. For stratospheric ozone, it accounts for 90% of the total ozones, and it can block much of the UV lights from the sun and protect humans from cancers and skin burn, and thus this one is a good ozone. Most of the scientists have worked on the ozone hole. Actually, it is the stratospheric ozone. The tropospheric ozone is coming from the pollution, which would cause the respiration problems, and thus this one is a bad ozone. Now we are focusing on stratospheric ozone particularly. Here is the global distribution of stratospheric ozone. We can see that at different seasons, the ozone in the tropics are somehow low, expect the Antarctic ozone hole, and normally higher at the mid-latitudes. The reason is that at tropics, there would be a high ozone production rate due to these chemical reactions, and the production of ozone in tropics actually have supported the global ozone. And due to the global circulation of atmosphere, the ozone would be slowly transferred towards the poles and accumulate at mid and high latitudes. That's why there will be higher ozone at mid latitudes. Well, with the data of yearly total column ozone, it is observed that except for the polar ozone, the mid latitude ozone also decreases at different seasons, which may affect a large population, especially in northern hemisphere. So there are several reasons for the loss of ozone in mid-latitudes. The first is the effect of volcanoes. This chart shows the ozone has decreased about 8%, and the volcano eruption would directly emit the aerosols. From both charts, we can see that in 1980s and 1990s, the two biggest volcano eruption has decreased the ozone a lot and obvious. The first of is the direct impact. The volcano eruption would directly impact some HCl into the stratosphere. For example, the volcano eruption in 1980s, which this one has emitted 10% of total stratosphere HCl, and which the chloride would act as a catalyst for ozone destruction. And the second effect that is aerosols. The aerosols could provide more surface for chemical reactions, as the NOx would be hydrolyzed to nitric acid, which is a reservoir for the radicals, and there will be less ozone reduction due to NOx, but there will be more impact of clocks on ozone reduction. So the volcanoes would accelerate the ozone reduction. This one shows the stratospheric water vapor increase at mid-latitudes, which is almost 30%. As we all know, the water vapor is a source of Hawk's radicals, and the Hawk's radicals directly lead to the loss of ozone. And this is the main reasons for mid-latitude ozone loss. That's all. Thank you.